Good morning, students. My name is Sonal Gupta, faculty in Computer Science Department in Global Institute of Technology. Today, we will learn about image distortions. Now, in this unit, we will cover up the following contents. First of all, we will discuss about introduction. What is image distortion methods? And second was degradation model. Third is noise model. Fourth is noise removal distortions method. Next is inverse filters. And last is homomorphic filters. In this unit, we will cover up these topics. So now we will come on introduction. In this image distortion methods, the operation of taking a corrupt or noisy image and estimate the clean as a original image. The corrupted image may come in many forms such as motion blur, noise blur, and camera misfocus, etc. The purpose of image distortion is to undo the defect which degrade an image. There are various sources of such degradation which may be grouped into the following categories. They may be as a point degradation, second one is spatial degradation, third is temporal degradation, fourth is chromatic degradation, and five is a combination of all above which are discussed here. The classification of image distortion techniques are two types. First one is deterministic method, second one is non-deterministic methods. The deterministic methods are also classified in two categories. First is linear method and second one is non-linear methods. In the deterministic method, we know prior knowledge about the degradation of image is known or known. If the degradation of image is non-prior, then we will use the deterministic method are used. If we know such about degradation of image is not known, then we use non-deterministic methods. Now we will come on degradation model. The degradation model is a image distortions method in which the process of recovering the original image from degraded image and also the understand the image without any artifacts error. The image distortion method can be considered as direct techniques when their results and produced in a simple one-step fashions. In the original image gets convolved with degradation function h comma y and noise gets added to it. The original image fx comma y. By using the degradation function h, we will add noise data in this image. Hence, to remove the degradation function, or also called convolutions, we need to apply inverse filtering to the degraded image. There are two basic approaches to model in the image degradation effect. First one, period modeling, and second, post-period modeling. In the period modeling, two arbitrary image field measurements are made on physical imaging system, digitizing and display to determine the response. In post-period modeling, to develop the model for image degradation based on measurement of a particular image to be restored. The degradation occur due to some image sensors noise, blur due to misfocus, blur due to motion, noise from transmission channel, blur due to transmission channel. They may be occur the degradation on image. Now we will come on noise model. The noise model produce a undesirable effect such as artifacts, unrealistic edges, unseen lines, corners, blurs objects, and disturbed background scenes. To reduce these undesirable effects, superior learning to noise model is essential for further processing. In the digital, noise may arise from various kind of sources such like a CCD and CMOS sensors. The common noise model are used in the digital image processing, the Gaussian model, Taylor model, gamma model, impulse model, exponential model, and last one is uniform noise model. These are above models are used for noisy models. The next is noise removal distortion method, that how to remove the noisy in the distortions model. The noisy removal distortion are achieved by filters. Those filters can be classified in the following basis. There are basically three types of filters: mean filter, orthostatic filters, and adaptive filters. In the mean filters, they are also categorized in four parts. First one is arithmetic mean filter. In this arithmetic mean filters, the process is compute the average value of the corrupted image. The corrupted image g x comma y in the area defined by window x x comma y. Window s x comma y. The formula is f dash x comma y is equal to 1 upon m n summation of g m comma n. It is a simply smooth an image. It will reduce the noise blurring to increase. Second is geometrical mean filters. In this filter, eliminate the Gaussian noise but is ineffective for paper type noise. It is represented as f dash x comma y is equal to pi g m comma n power 1 upon m. It is better than arithmetic mean filters, but it will lose some information of an image during filtering. So it is few used in the image processing system. Third one is harmonic mean filter. The harmonic field filter work well for removing salt type noise and Gaussian noise. It is represented as f dash x comma y is equal to m n upon summation of 1 upon g m comma n. And for the contra harmonic mean filter, the contra harmonic filter is given by f dash x comma y is equal to summation g m comma n power q plus 1 divided by summation of g m comma n power q, where q is the order of filters. If q is positive value, then filters are paper noise. For q is negative value, then which filter are used for salt noise. And second one is order static filter. Order static filters are generally used for not based on convolution. The pixels that come under the mask for simply ordered. There are basically four types: median filter, maximum minimum filters, midpoint filter, alpha trimmed filter. First one is median filter. In this median filters, the pixels value is replaced by median value of gray level of neighboring pixels. The formula is f dash x comma y is equal to median g s comma t. The median filter select the middle value in a sorted list. Second is maximum filters. These filters select the largest value in the sorted list. The largest value is the element of the list. The filter is used for removing paper type noise. The minimum filters are used for smallest value. It is select the smallest value in which the first element of the sorted list. It is very effective in eliminating salt type noise. Next one is midpoint filter. The midpoint filters select the midpoint. The midpoint is f1 plus f2 divided by 2, the average value of minimum and maximum value. This filter is very effective in removing Gaussian noise and uniform noise. Next is alpha trimmed filters. It is based on the concept of computation of average pixels that fall within the window. Next, adaptive filters. Adaptive filters are defined by following aspects: the signals being processed by the filters, the structure that defines how to output signals of the filters is composed from its input signals. The parameter within this structure that can be iteratively changed to alter the filter's input-output relationship. The adaptive algorithms that describes how the parameters are adjusted from one time instant to the next. There are basically two types: adaptive local noise reduction filters and adaptive median filters. Then now come on inverse filters. The inverse filter is a linear type filters. The purpose of the image distortion is to estimate to recover the scene without image degradation or distortions caused by non-ideal image systems. Inverse filtering is one of the techniques used for image distortions to obtain the recovered image f(x, y) from the image data gx, y. So that f(x, y) is equal to fx, y. In the ideal situation, n hx, y is equal to 0 and hx, y multiply h dash x, y is equal to delta x, y. And next is homomorphic filtering. Homomorphic filtering is generalized techniques for signal and image processing. It is a nonlinear mapping to a different domain in which linear filter techniques are applied, followed by mapping back to the original domain. It is developed in the 1960s by Thomas Stockman, Alan B. Opinium, and Ronald W. Soper. It is normalize the brightness across the image and increase contrast. Here, homomorphic filtering is used to remove multiplicative noise. The homomorphic filters are based on two terms: illumination and reflectance. Light falling on the object is called illumination, and light reflecting from object is called reflectance. The key approach in homomorphic filtering is to separate illumination and reflectance components from the image f(x, y). The homomorphic filtering can be used for improving the appearance of a grayscale image by simulation intensity range compression. mx, y is equal to ix, y multiply rx, y, where m is equal to image, I is equal to illumination, and r is equal to reflectance. Thank you.